Hello students, welcome back. So we are doing laws of indices exercise 7b, isn't it? In our previous videos we have completed till question number 9 and today we'll start from question number 10 onward. Okay, so let's begin. This is question number 10 from exercise 7b and this is the given condition to us: 5 to the power minus p equals to 4 to the power minus q equals to 20 to the power r. So this is the given condition. We are asked to prove 1 upon p equals to 1 upon p plus 1 upon q plus 1 upon r equals to 0. Okay, so let's do this. So if we have this condition like this, a equals to b equals to c, what we usually do is we suppose everything as k. Okay, 5 to the power minus p equals to 4 to the power minus q equals to 20 to the power r equals to k. Say we have done this type of question, isn't it? If this equals to this equals to this, then we suppose this equals to k. Okay, which means 5 to the power minus p equals to k, 4 to the power minus q equals to k, and 20 to the power r equals to k. Okay, so or 5 to the power minus p equals to k. Now this 5 is in the numerator. We don't have number in the denominator, means there is always 1 in the denominator. We don't usually write that because we understand there is 1 in the denominator. So the power of this 5 is minus p. If I take this number to the denominator, the power changes to plus p, isn't it? 5 to the power minus p becomes 5 to the power plus p equals to k. Now we have 1 in the denominator of k, so we invert this number. We apply invertendo, which means the number from the denominator goes to the numerator, and from the number from the numerator comes down to the denominator. Okay, 5 to the power p becomes 1 upon k. Here the power of the sign of the power does not change. Here you see 5 to the power minus p became 5 to the power plus p when we took the number to the denominator, isn't it? But here when we brought this number from denominator to numerator, the sign is plus p. 5 to the power plus p was in the denominator, and in the numerator also 5 to the power plus p. Because this is just an invertendo, we have applied invertendo in both left hand side and right hand side. So when we apply invertendo, power does not change. Okay, this is invertendo. Sign of the power does not change. 5 to the power plus p from denominator goes to the numerator, and 1 comes down to the denominator. The same thing is applied here. 1 goes to the numerator, k comes down to the denominator. Now, or you know that if a to the power m equals to x, then what we write is a equals to x to the power 1 upon m, isn't it? If a square equals to x, then we write a equals to square goes to the right hand side and becomes root under x, which means a equals to x to the power 1 by 2. Square when goes to the right hand side becomes 1 by 2, the power. Okay, if a cubed equals to x, then a equals to x to the power 1 by 3, isn't it? Because a equals to cube root of x. This cube root of x means x to the power 1 by 3, isn't it? The same thing, if the power is m, goes to the right hand side, it becomes 1 upon m. So here 5 to the power p we take to the right hand side and make it as 1 upon p. Okay, 1 upon p. 5 to the power p goes to the right hand side, p only the power p goes to the right hand side and becomes 1 upon p. Now this power 1 upon p applies to both the numerator and the denominator. So 1 to the power 1 upon p means 1 to the power any number. 1 to the power any number is always 1. Okay, 1 to the power 100 equals to 1, 1 to the power minus 100 equals to 1, 1 to the power x equals to 1, 1 to the power minus x equals to 1. 1 to the power any number, 1 to the power 0 equals to 1. 1 to the power any number is always equal to 1. Okay, so this means 1 to the power 100 is 1, means 1 to the power root of 100. 1 to the power 100 means 1 multiplied 100 times. No matter how many times you multiply 1, you get 1. 1 to the power minus 100 means 1 upon 1 to the power 100, isn't it? So 1 upon 1 into 100 times. This means 1 upon, no matter how many times you multiply 1, you get 1. 1 upon 1 means 1, isn't it? So 1 to the power x means you multiply any number of times. 1 multiplied any number of times is always 1, isn't it? 1 into 1 into 1 into 1 into, no matter how many times you multiply 1, you get 1. So this means, or 5 equals to 1 to the power 1 upon p means 1, and k to the power 1 upon p comes here, k to the power 1 upon p. Okay, 5 equals to 1 upon k to the power 1 upon p. Let's assume this as equation 1. Equation 2, we have 4 to the power minus q. 4 to the power minus q equals to k, isn't it? Or 1 upon 4 to the power q equals to k. Or now we apply invertendo. 4 to the power q equals to 1 upon k. Now 4 equals to, you take this power q to the right hand side, 1 upon k to the power 1 upon q. This q goes to the right hand side, becomes 1 upon q. Or 4 equals to 1 upon k to the power 1 upon q, isn't it? So this is equation 2. Okay, now we have 20 to the power r equals to k. 20 to the power r equals to k, which means 20 equals to k to the power 1 by r. This power r goes to the right hand side, becomes 1 upon r. Or 20 means you can write 4 into 5, 4 5s are 20 equals to k to the power 1 by r. So 4 means 1 upon k to the power 1 upon q. 1 upon k to the power 1 upon q. This is 4 from equation 2. Into this into comes here. 5 means 1 upon k to the power 1 upon p. 1 upon k to the power 1 upon p equals to k to the power 1 upon r. Okay, so 1 upon this k and k, when we multiply this, what happens? K to the power 1 upon q plus 1 upon p. Same base, k and k, means power gets added when we multiply. Okay, when we multiply the numbers having same base, the powers 1 upon q and 1 upon p, they adds up, equals to k to the power 1 upon r, means k to the power minus 1 upon r, isn't it? K to the power plus 1 by r, when we take to the denominator, becomes k to the power minus 1 by r. Now we apply invertendo again. The number from the denominator goes to the numerator. Here also same thing. K to the power 1 upon q plus 1 upon p equals to k to the power minus 1 by r. Okay, this number from the denominator goes to the numerator here in the left hand side. The same thing is done in the right hand side. Number from the denominator goes to the numerator, k to the power minus 1 by r. Sign of the power does not change when we apply invertendo in both the sides, left hand side and right hand side. Okay, this means k and k same base, means their power should be equal. So 1 upon q plus 1 upon p can be written as 1 upon p plus 1 upon q. Same thing, isn't it? Equals to minus 1 upon r. Or you can write 1 upon p plus 1 upon q minus 1 upon r, we take to the right hand side, plus 1 upon r equals to 0. So 1 upon p plus 1 upon q plus 1 upon r equals to 0, isn't it? This is what we were asked to prove, and this is, we have proved it. Hence proved. Hence proved. Okay, I hope you got this. Now let us do the next question. Now let us do question number 11 from exercise 7b. So if m is not equal to n, m and n are not equal, and the given condition is this, okay, m plus n whole to the power minus 1, and here this into, there is no sign, means into, okay, m to the power minus 1 plus n to the power minus 1. Here both m plus n to the power minus 1, here m to the power minus 1 plus n to the power minus 1. These two are totally different, okay. A square plus b square and a plus b whole square. Here we are applying square square and there is plus sign in between them. Here a plus b whole square. These two are totally different thing, not equal to each other, okay. But a square into b square and ab square, these two are same thing, but these two are different thing, okay, because there is plus. If there is plus or minus sign, then the value is changed, okay, the value is totally different. Now m plus n whole to the power minus 1 and m to the power minus 1 plus n to the power minus 1, these two are totally different. When these two are multiplied, we get m to the power x and n to the power y. This is the given condition. We are asked to prove x plus y plus 2 equals to 0, okay. So let's do this. Since m plus n whole to the power minus 1 into m to the power minus 1 plus n to the power minus 1 equals to m to the power x into n to the power y. Okay, now we take this number down to the denominator, 1 upon m plus n whole to the power 1, isn't it? Power minus 1, when we take the number to the denominator, power changes to plus 1. So if the power is plus 1, we don't usually write plus 1 power, isn't it? Because when we write a, we should understand the power of this a is plus 1, okay. Unless the power is mentioned, we should understand the power is 1. If we write 5, we should understand the power of this 5 is 1, okay. So the power of this m plus n together is 1 into, this becomes 1 upon m plus this becomes 1 upon n. Power changes to plus 1, here plus 1. M to the power minus 1 when taken to the denominator, m to the power plus 1. N to the power minus 1 when taken to the denominator, n to the power plus 1 equals to m to the power x, n to the power y, or 1 upon m plus n into, okay, let's take the LCM of the denominators, m and n, we get mn. M into n is mn. M when multiplied with n gives us mn, so n into 1, n plus n when multiplied with m gives us mn, so m into 1, m equals to m to the power x into n to the power y. So here we have n plus m, here also m plus n, the same thing, 2 plus 3 and 3 plus 2, both are equal, isn't it? 5. So n plus m, same thing, we cancel these two, okay. So we have 1 into 1, here we have 1 here, 1 into 1 is 1, 1 upon mn equals to, or, okay, we must write or, equals to m to the power x, n to the power y. Now we take this m to the numerator, m to the power minus 1 into n to the power minus 1 equals to m, okay, this is m to the power x, n to the power y. Now m and m base same, m and m, and there is into sign, okay. If there is plus sign or minus sign in between them, we cannot apply this. Now there is multiplication sign in between m and n, so we can apply this. M and m same base means their power should be equal, or x equals to minus 1, x equals to minus 1, and n and n same base, so their power should be equal, y equals to minus 1, okay. So we got x is minus 1 and y as minus 1. Now let's do the left hand side of this. LHS equals to x plus y plus 2. So we are going to use this and prove this equals to 0, isn't it? So x is minus 1, okay, plus y is minus 1 plus 2. So here we have plus outside the bracket, so plus into minus, minus 1, plus into minus, minus 1 plus 2. So these two numbers are same sign, minus 1, same sign means we must add the numbers, isn't it? Minus 1, minus 2 plus 2. So these two are different numbers, equal numbers but different sign, plus 2 and minus 2. This means this equals to 0, equals to right hand side, hence proved. I hope you got this. Now let us do the next question. 5 to the power x plus 1 equals to 25 to the power x minus 2, and we are asked to find the value of this expression, isn't it? So first we find the value of x and then we can find the value of that expression. So here we have, or since this is the given condition, okay, we copy this first. 5 to the power x plus 1 equals to 25 to the power x minus 2. This is the given condition. So we write 5x plus 1. I am trying to make the bases equal, okay. 5 to the power x plus 1 equals to, this is 25, isn't it? Means 5 is squared. 5 is squared into x minus 2. This x minus 2 is x minus 2. 25 means 5 is squared. 5 5s are 25. Okay. Or 5 to the power x plus 1 equals to 5 to the power 2 into x. 2x minus 2 to the 4. 5 and 5 same base means their power should be equal. Okay. Or x plus 1 equals to 2x minus 4. If the bases are equal, their power should be equal. Or this is x, we take this plus 2x to the left hand side, minus 2x equals to minus 4 we already have in the right hand side. Now we take this plus 1 to the right hand side, minus 1. Or plus x and minus 2x means minus x, sign of greater number comes here. Plus x minus 2x, opposite sign, we subtract. 2x minus x is x, sign of greater number comes here, minus. Minus 4 minus 1, that is minus 5. Minus and minus cancels out, or x equals to 5, isn't it? So we found the value of x, that is 5. Now let us find the value of this expression. So we have 3 to the power x minus 3 into 2 to the power 3 minus x. This means 3 to the power x means x is 5. So instead of x, I write 5 minus 3 into 2 to the power 3 minus 5. Okay. So 3 to the power 5 minus 3 is 2. 5 minus plus 5 minus 3 is 2 into 2 to the power 3 minus 5 is minus 2. 3 minus 5 is minus 2, isn't it? So 3 squared is 9. Now into 1 upon 2 squared, minus 2 when we take to the power, when we take this number to the denominator, the power minus 2 changes to plus 2. This means 9 ones are 9 upon 2 squared is 4. 9 upon 4, isn't it? So let's divide, because this is an improper fraction. The number in the denominator is smaller than the numerator. So if the number is improper fraction, we must change it into mixed fraction. So 9 divided by 4 is 4 2 is 8. 9 minus 8 is 1. So this 2 remains here. This remainder goes up and this divisor comes down here. This means 9 upon 4 means 2 whole 1 by 4. This is the answer for question number 12. I hope you got this. Now let's do the next question. Number 13. So this is the equation given to us. 4 to the power x plus 3 equals to 112 plus 8 into 4 to the power x. And we are asked to find the value of this. 18x to the power 3x, isn't it? So first we find the value of x from this equation and then we put the value of x here. Okay. Then we can find the value of that number. Now since we have 4 to the power x plus 3, isn't it? You can write 2 squared. 2 squared is 4. 2 to the 4. X plus 3. This 112 we write as it is. Plus 8 means 2 cubed, isn't it? Into 2 cubed is 8. 2 into 2 into 2. 2 to the 4, 4 to the 8. 8 means 2 cubed. 2 multiplied 3 times gives us 8. So 4 to the power x means 2 squared into x. This x was already there, so 2 squared means 4. So 2 to the power 2 into x is 2x plus 2 3 is 6. Okay, equals to 112 plus, now we have same base 2 and 2 and there is multiplication sign in between them. That means the power should be added. 2 to the power 2x plus 3. If the bases are equal and there is multiplication sign, we must add the powers, isn't it? 2x plus 3. Now let us bring this plus 2x plus 2 into 2 to, plus 2 to the power 2x plus 3 to the left hand side. 2 to the power 2x plus 6, we already have this number here, minus this plus number becomes minus 2 to the power 2x plus 3 equals to 112, or 2 to the power 2x, 2 to the power 2x, isn't it? Let's take the power 2 to the power 2x common. 2 to the power 2x common. We have 2 to the power 6, isn't it? 2 to the power 6, because 2 to the power 2x into 2 to the power 6 gives us same base power 2 to the power 2x plus 6. If the bases are equal, their power should be added. So 2 to the power 2x plus 6 means 2 to the power 2x into 2 to the power 6. We take the power 2 to the power 2x common. Here also we have 2 to the power 2x, so minus this number is taken out, so 2 cubed remain within. What I mean to say by this is, when we multiply these numbers, we must get this, isn't it? So 2 to the power 2x into 2 to the power 6 gives us 2 to the power 2x plus 6, minus, plus into minus is minus. 2 to the power 2x into 2 to the power 3 gives us 2 to the power 2x plus 3 equals to 112, or 2 to the power 2x, 2 to the power 6 means 64, isn't it? 2 into 2 into 2 into 2 into 2 into 2. 1, 2, 3, 4, 5, 6. 2 to the 4, 4 to the 8, 8 to the 16, 16 to the 32, 32 to the 64. So 2 to the power 6 means 64, minus 2 cubed means 8. 2 into 2 into 2. 2 to the 4, 4 to the 8 equals to 112. So let me continue this here. So 2 to the power 2x, or 2 to the power 2x into 64 minus 8. 64 minus 8. 14 minus 8 is 6. 14 minus 8 is 6. Okay. Now this becomes 5. 56, isn't it? 64 minus 8 is 56. Equals to 112, or 2 to the power 2x, this is into, isn't it? So this number goes to the denominator by cross multiplication. 112 by 56. Now 7 8s are 56, 7 1s are 7, plus 4 11, 42. 4 in 4 and 2 becomes 42. 7 6 are 42, 8 1s are 8, 8 2s are 16, or 2 to the power 2x equals to 2. 2 means 2 to the power 1, because when we write 2, we should understand the power of this number is 1, isn't it? The bases are equal, 2 and 2, that means the power should be equal, or you can write 2x equals to 1. This means x equals to 1 by 2. This 2 goes to the denominator. Okay. Since 2 and 2 power bases are equal, their powers 2x and 1 will be equal. 2x equals to 1. Now this 2 into x, this 2 goes down to the denominator. X equals to 1 by 2. So we found the value of x. Now let us put this value of x in this expression. So 18, we are asked to find the value of this. 18 x to the power 3x. This gives us 18 into x means 1 upon 2, 1 upon 2, 3 x means 1 upon 2, or 2 9 ja 18, because 2 is in the denominator, 18 is in the numerator, so 2 9 ja 18, 9 1 ja 9. 9 means 9 1 ja 9. 9 means 3 squared. 3 squared into 3 1, this 9. 9 means 3 squared, okay, 3 3 ja 9. 3 squared is this 9. Into, now this power, I must not forget this power. 3 1 ja 3 upon this 2. So 2 and 2 can be cancelled because this 2 is in the denominator and this 2 is in the numerator. This gives us 3 cubed. 3 cubed. 3 cubed means 3 into 3 into 3. 3 into 3 into 3. 3 multiplied 3 times. 3 3 is 9, 9 3 is 27. So this is 27. This is the answer for question number 13. Now let's do the next question. 1 of 14, okay. Solve for x. We are asked to find the value of x from this given equation. So 4 to the power x minus 1 into this. Okay, or 4 to the power x minus 1 can be written as 2 to the power 2x minus 1, because 2 squared is 4, so x minus 1 was already there, into 0.5 means 5 upon 10, isn't it? When we remove the decimal from one digit, before one digit, we put 1 0 in the denominator. Okay, so this is 3 minus 2x. The power is 3 minus 2x, excuse me. So here we have 1 upon 8 to the power minus x, isn't it? So 1 upon 8 to the power minus x. If I take this 8 to the numerator and 1 to the denominator, the power changes to plus x, isn't it? How is it this? How did this happen? So this means 1 to the power minus x upon 8 to the power minus x. 1 upon 8 whole to the power minus x. This power minus x applies to both the number, so we put the power individually. So I take this number 8 to the power minus x to the numerator, 8 to the power plus x, and 1 to the power minus x to the denominator, 1 to the power plus x. So 8 to the power x is 8 to the power x, and 1 to the power x means 1 to the power any number is 1. So 8 to the power x upon 1, isn't it? Are you getting me? I hope so. So this means 8 to the power x. This 8 goes to the numerator, power minus x changes to plus x. 1 comes down to the denominator, the power changes to plus x. So 1 to the power x means 1. 1 to the power any number is always 1, okay. So this is 5 1s are 5, 5 2s are 10. Or 2 to the power 2 into x, 2x minus 2 1s are 2. 2 into x, 2x minus 2 1s are 2. Into, now this is 1 upon 2 whole to the power 3 minus 2x, isn't it? So this means 2 goes to the numerator, this minus 2x becomes plus 2x, plus 3 becomes minus 3, okay. How did this happen? See here, 1 upon, now see here, this power, if I take down to the denominator, actually this is 1 upon 2, this power applies to 1 and 2 both. So 1 to the power 3 minus 2x, 1 to the power 3 minus 1 to the power 3 minus 2x upon 2 to the power 3 minus 2x, okay. Now I take this number to the numerator, 2 minus 2x becomes plus 2x, plus 3 becomes minus 3, okay. Now 1 this to the power 1 is 1 to the power anything is always 1. So 1 to the power minus 3 plus 2x. So 1 to the power minus 3 or plus 2x or 1 to the power any number is always 1. So 2 to the power 2x minus 3 upon 1. No need to write that, isn't it? Are you getting me? I hope so. This is actually 2 to the power 1 upon 2 to the power 3 minus 2x. 3 minus 2x is actually 1 upon 2 cubed into 2 to the power minus 2x, isn't it? Same base, power gets adds up. So I take this number to the numerator, 2 to the power 2x minus 2x becomes plus 2x, into I take this number to the numerator, 2 to the power minus 3, plus 3 becomes minus 3. Now same base, we add up the power again, 2 to the power 2x minus 3, isn't it? The same thing I wrote here, isn't it? Somewhere. Oh, I erased it. I hope you got this. Now 1 upon 2 to the power 3 minus 2x can be written as 2 to the power 2x minus 3, minus 2x becomes plus 2x, plus 3 becomes minus 3 when this 2 goes to the numerator. 1 goes to the denominator and the power becomes this. 1 to the power any number is always 1, so no need to write that. Equals to 8 to the power x, means 8 means 2 cubed x. Okay, 2 cubed is 8, and this x is this x. So here we have into sign, isn't it? So you can see the two bases are equal and there is multiplication sign in between them. That means their power should be added. So 2 to the power 2x minus 2 plus 2x minus 3 equals to 2 to the power 3x. This power and this power are being added because same base and multiplication sign in between them. This gives us 2 to the power 2x plus, and this 2x is also plus, means 4x minus 2 minus 3, same sign, minus 2 minus 3, so minus 5, minus 2 minus 3 minus 5, plus 2x plus 2x plus 4x equals to 2 to the power 3x. Now 2 and 2 same base, equal base, means power should be equal. Let me continue here. 2 and 2 equal base means power should be equal. So 4x minus 5 equals to 3x, or 4x minus 5 equals to 3x. 4x minus 5 equals to 3x. Okay, now 4x we have in the left hand side. Let's bring this 3x becomes minus 3x equals to minus 5 we take to the right hand side becomes plus 5. Okay, minus 5 when we transpose to the right hand side becomes plus 5, plus 3x when you bring to the left hand side becomes minus 3x. Our 4x minus 3x is x, isn't it? Sign of greater number comes here, plus equals to 5. So we were asked to find the value of x, and the x is equal to 5. Okay, I hope you got this. Now let's do the next question. Question number 2 of 14. Okay, so before we do this question, let's see the rule. If a to the power m whole to the power n, then we can write this as a to the power m into n. That is a to the power mn, isn't it? If a to the power m whole to the power n, then we can write a to the power m into n equals to a to the power mn. Okay, this is the rule of indices. So, or a to the power, this is m to the power n. Okay, this means a to the power mn, a to the power mn. Mn means we multiply all this, isn't it? 2 3s are 6x plus 2 5s are 10 into a to the power m into n, means mn, x into 4, 4x equals to a to the power 8x plus 12. Or same base and there is multiplication sign in between them, that means we must add up the power. A to the power 6x plus 10 plus 4x equals to a to the power 8x plus 12. Or a to the power 6x plus 4x is 10x, plus 6x plus 4x is plus 10x, and this is plus 10 equals to a to the power 8x plus 12. You see, a and a same base, that means their power should be equal. Or 10x plus 10 equals to 8x plus 12. Or 10x, let's bring this plus 8x to the left hand side, minus 8x equals to 12 is already in the right hand side, 12, isn't it? So we take this plus 10 to the right hand side, minus 10. Let me continue here. 10x minus 8x plus 10x plus 10x minus 8x. 2x. 10x minus 8x is 2x equals to 12 minus 10 is 2. Or x equals to, we have 2 here, let's take down this 2 to the denominator, 2 and 2 gets cancelled, or x equals to 1. So the value of x, we were asked to find the value of x, and the value of x is 1. Now let us do question number 3 of 14. Okay, we are asked to find the value of x. Solve means find the value of x. Okay, so 81 is actually 3 to the power 4, isn't it? 3 into 3 into 3 into 3. 3 3s are 9, 9 3s are 27, 27 3s are 81. 3 3s are 9, 3 3s are 9, 9 9s are 81. Okay, have we got this? Now 81 means 3 to the power 4 into 3 upon 4, 3 upon 4 minus, now the power is minus 2 upon 5 and 32 is in the denominator. What we do is 32 we bring to the numerator and the power becomes plus 2 upon 5. Are you getting me? 1 upon 32 to the power minus 2 by 5. This means 1 to the power minus 2 upon 5 upon 32 to the power minus 2 upon 5, isn't it? This power minus 2 upon 5 is for both the numbers, so I write 1 to the power minus 2 upon 5 and 32 to the power minus 2 upon 5. This means I bring this 32 to the numerator, 32 to the power 2 upon 5 upon 1 to the power 2 upon 5. So this is 32 to the power 2 upon 5. 32, okay, this is 32. 32 to the power 2 upon 5 upon 1 to the power any number is always 1. 1 to the power any number is always 1. Okay, so we need not write the power. So this means 1 is always there in the denominator of any number if there is no number. So 32 to the power 2 upon 5 plus x, the same thing applies here, into 2 to the power 1 minus 1 becomes plus 1 if I bring this 2 to the numerator. So 1 upon 1. 1 upon 1 means 1 to the power 1 means 1. So we need not write 1 because there is always 1 in the denominator. So 2 to the power 1 means 2. So we need not write the power here. So 2 to the power 1 means 2. Into 2 to the power 0 means 1. Any number raised to power 0 is always 1 except 0 to the power 0 is not equal to 1. 0 to the power 0 is undefined. Other than 0, any number raised to power 0 is 1. So 2 to the power 0 is 1 equals to 27. Now this 4 and 4 can be cancelled. So 3 cubed, okay, this equals to, or we must write or, 3 cubed minus 3 cubed, 32 to the power 2 upon 5 means 2 to the power 5. 2 into 2 into 2 into 2 into 2. 1, 2, 3, 4, 5. 2 to the 4, 4 to the 8, 8 to the 16, 16 to the 32. 32 means 2 to the power 5. 1, 2, 3, 4, 5 into 2 upon 5 plus 2 1s are 2, 2 into x is 2x equals to 27. This 5 and 5 can be cancelled, or 3 cubed means 27 minus 2 squared means 4. 3 cubed means 27, this minus comes here, this 5 and 5 is cancelled, so 2 squared, isn't it? 2 squared is 4, 2 to the 4 plus 2x equals to 27, or 2x equals to, we have 27 in the right hand side, let's take this plus 27 to the right hand side, becomes minus 27, minus 4 we take to the right hand side, plus 4. Okay, this plus 27 when we transpose to the right hand side, minus 27 minus 4 becomes plus 4. Now plus 27 minus 27 cancels, or x equals to, we have 4 upon this 2 comes down to the denominator. 2 1s are 2, 2 2s are 4. Therefore, x equals to 2. I hope you got this. The value of x is 2. Answer for question number 3 of 14. Okay, that's question number 4 of 14. So we are asked to find the value of x from this equation. So this is 2 to the power 3x, okay, into, we can write 2 cubed. 2 to the power 3x, first let me copy this as it is, 3x plus 3 minus 2 to the power 3x plus 1 equals to 48. So 2 to the power 3x plus 3 as it is, I copied this number as it is, plus 2 to the power 3x plus 1, I bring to the left hand side, becomes minus 2 to the power 3x plus 1 equals to 48. 48 is now left in the right hand side. This number is in the left hand side, plus 48 is in the right hand side. Okay, or 2 to the power 3x 2 cubed, same base, power gets added, 3x plus 3 minus 2 to the power 3x into 2 to the power 1, same base, power gets added, isn't it, equals to 48. 2 to the power 3x into 2 cubed means same base, 2 to 3x plus 3. So 2 to the power 3x plus 3 can be written as 2 to the power 3x into 2 cubed, the same thing. I hope you got this. Or let's take this 2 to the power 3x common, 3x, now we have 2 cubed within the bracket, minus 2 to the power 1 means 2 equals to 48. Or 2 to the power 3x, 2 cubed means 8 minus 2. 2 cubed means 2 into 2 into 2, that is 8 minus this 2 equals to 48. Okay, 2 to the power 3x, 2 to the power 3x into 8 minus 2 is 6 equals to 48. 48. 2 to the power 3x, 8 minus 2 is 6 equals to 48. Or 2 to the power 3x equals to 48. This 6 goes down to the denominator by cross multiplication because there is into sign, isn't it? So 6 1s are 6, 6 8s are 48. Or 2 to the power 3x equals to 8. 8 means 2 cubed. 8 means 2 cubed. 2 cubed is 8, isn't it? 8 means 2 cubed. So bases are equal, 2 and 2, that means power should be equal. Or 3x equals to 3, or x equals to, this 3 is already in the right hand side, now let's take this 3 to the denominator by cross multiplication, 3 3 cancels, or x equals to 1. So the value of x is 1. Okay, answer for question number 5 of 14. So we are asked to solve this equation, means we are asked to find the value of x from this equation. Okay, so this is 3 into 2 to the power x, 3 into 2 to the power x plus 3 1s are 3, I am just multiplying within the bracket, minus 2 to the power x plus 2. 2 means, okay, let me write as it is for the time being. This is 5 plus 5, I take this number to the right hand side, minus 5. Now 2 to the power x means 2 to the power x into 2 squared, isn't it? 2 to the power x into 2 squared, same base, power can be added, x plus 2. So 2 to the power x plus 2 can be written as 2 to the power x into 2 squared. Okay, now you can see 3 into 2 to the power x minus 2 to the power x into 2 squared equals to minus 5 plus 3, I take to the right hand side, this plus 3 minus 3. Okay, so 2 to the power x, 2 to the power x is taken common, 2 to the power x is taken common. Now 3 remains within the bracket, minus 2 to the power x is taken common, 2 squared is remained within the bracket, 2 square remains within the bracket. Okay, 2 to the power x, 2 to the power x, 2 to the power x taken common. This 3 minus 2 to the power x is taken common, 2 squared remains within the bracket. Minus 5 minus 3 minus 8. Or 2 to the power x equals to minus 8 is already in the right hand side upon this is into, isn't it? This goes to the denominator. So 2 squared is 4, 2 squared is 4 plus, minus 4 plus 3. 2 squared is 4, minus 4 plus 3 is minus 1, isn't it? 2 squared is 4. So this is minus 4 and this is plus 3, minus 4 plus 3 minus 1. So minus and minus cancels out. 2 to the power x equals to 8 means 2 cubed, and there is 1 in the denominator. Every number has 1 in the denominator. We need not write 1 in the denominator. 8 is 2 cubed. So 2 and 2 equal base. That means therefore x equals to 3. So we are asked to find the value of x equals to 3. Okay, this is the last question from this exercise 7b, question number 6 of 14. Okay, we will solve this. Solve means we are asked to find the value of x from this equation, isn't it? So we have 9 to the power x plus 2 equals to 720 plus 9 to the power x. We bring this 9 to the power x to the left hand side, okay? Or this can be written as 9 to the power x into 9 squared. Same base, power gets added, x plus 2. So minus 9 to the power x equals to 720. This plus 9 to the power x becomes minus 9 to the power x when we bring to the left hand side, equals to left hand side from the equals to, okay, this equal to left hand side. So 9 to the power x, 9 to the power x, we take common 9 to the power x. Within the bracket remains 9 square, that is 81. 9 squared means 81 because 9 to the power x is taken common. Now 9 squared remains within the bracket, that is 9 squared is 81 minus 9 to the power x is taken common, so 1 remains here, equals to 720. Or 9 to the power x equals to 720 is already in the right hand side. 81 minus 1 is 80. 80 goes to the denominator, isn't it? Because we have into here, that means this number goes to the denominator. 81 minus 1 is 80. 0 0 cancelled. 8 1s are 8, 8 9s are 72. Or 9 to the power x, 9 to the power x equals to 9. This 9, isn't it? 9 means there is always the power 1. If there is no power, we must understand the power of that number is 1, okay? Even if we write 0, the power of this 0 is 1. The power of 0 is never 0, okay? Whatever the number you write, the power is always 1. If the power is not mentioned, we should understand the power is always 1. So 9 to the power x equals to 9 to the power 1. That means bases are equal, means power should be equal. Therefore, x equals to 1. So this is the answer for question number 6 of 14. And this is the last question from this exercise. I hope you understood the concept of indices. Now we will move on to the next chapter, exercise 7c, in our next video, okay? Until then, take care, stay connected, study well. Thank you.